All right, so I guess we'll go ahead and get started. Good afternoon, everybody. I'm Elliott Chenger, and today I want to talk to you guys a little bit about, obviously, TextViews and localization, as you've seen for the past 5 to 10 minutes, if you've been sitting here. So today, just kind of so you understand what we're going to be going over exactly, first I want to talk a little bit about the Android text rendering system. We're not going to go into a whole lot of detail, but get an understanding of it. Then talk about typography in Android, how that works. Also get some definition around that. And then lastly, the two things I want to cover is kind of understanding what internationalization and localization is, and then as well, let's actually look at how we want to localize our text views in Android. So first and foremost, let's get started with it. Let me explain you Android text rendering. So this is a slightly abridged version of Android text rendering. If you've read the Roman Guy post about text rendering on Medium, which I'll have a link to on my website afterwards, the one thing you'll find about text rendering is that it's a very, very deep rabbit hole. In fact, a lot of the rabbit hole involves non-Java code, a lot of native code, as we'll kind of talk about a little bit. So when we talk about text views, a lot of people just kind of think of one package when we're talking about text views, and that's the widget package where text views is kind of living. But instead, there's two actual other packages that I think are really important to understand that are in coordination with the widget package itself to make text views actually work. So of the three, like I said, we have the widget, which is the text view that you guys probably are all very well aware of. The text package, which is basically everything that's going to be helping build and lay out the the actual text view and the text on screen and the graphics package. And so how that kind of looks as the landscape is, like I said, in the widget package you'll have the text view itself. In the text package you have things like layouts, dynamic layouts, boring layout, which those kind of actually figure out how to display the text on the screen, and then text paint, which holds all of the information about the fonts, how we're actually going to draw things on the canvas itself, and then there's a myriad of just other text classes from everything you need, like how to basically change text from right to left so that it's not garbled, vice versa. And so the text view actually works with all of these in conjunction. Don't think of them as all separate pieces. The text view is kind of the inception point for all of this. So what happens is the text view will go to the layout and it will ask the layout to figure out how much space it needs to actually display the text that we have for that text view. It will go to the text paint and it asks to understand how much room for the font it's going to need. And then like I said, there's probably about 15 to 20 other classes that are incredibly ingrained in the text view. If you've ever taken a look at the source code for it, it's pretty deep. So after kind of working with all of those, the next kind of interaction you'll see is the layout also kind of going to the text paint, because this is where all of the font metrics are stored. Everything that Android needs and the native libraries need in order to actually draw the text on the screen all happens between the layout and the text paint. And then finally, you'll notice that the layout actually communicates then directly with the canvas. And if anybody here has written a watch face, yet, and where you'll definitely be familiar with this, especially if you're dealing with text on there, because we don't have the view system at all. So you're directly working, between layout and canvas. So this is kind of, like I said, a very, very basic but hopefully helpful understanding of what's going on in Android when it's building the text view. It's taking your text, trying to figure out how to display it within the Android view system itself, actually trying to figure out how much space it's going to take, what the font's going to look like, and then drawing it to the screen. Now, like I said, Roman Guy has a post, and I will definitely make sure this is up on my website, that talks about basically everything that happens after the canvas. And that goes, like I said, extremely deep into native code that I myself, even though I've spent a lot of time in the text view, have not wanted to go through, purely because first and foremost, I haven't used C and God knows how long, and I need to brush up on those chops anyways. But right now, I'm just kind of like, stay over there. And then secondly, there's just that layer between JNI and the actual native layer is just really hard for us. Like, I feel like after that, I can't really do anything. So understanding it's great, but I'm not going to be able to do anything actionable. So that's basically, like I said, the overall of what's going on when you're using your text view and kind of all the components that are in play. So before we kind of get into the core of Android and topography, I figured that the really important thing is for all of us to understand some basics of topography. So to do this, I actually had to go and sit with a designer and understand more of actual topography and design speak around topography, and realized, once again, this is a huge topic. So I'm going to cover the stuff that's really important to Android specifically and not go into a lot of detail about things that we really just don't need to or shouldn't care about. So the first one that I'd like to bring up is baseline. So just making sure it looks good. So baseline is, as it says up there, an imaginary line which line of text rests upon. And in Android, we have really only two different ways of getting this. And to preface this, most of the stuff we're going to talk about in the topography and Android slides is not stuff that you're going to use on your day-to-day. Almost 95% of dealing with text views, you'll never even touch these APIs. But I've found that when I needed to figure out what was going on with a font, I was seeing a font that's rendering weird. These are the first places that I go to, because this actually gives me very detailed information about what Android thinks about the font is going on and how it's actually being rendered inside my text view. So going back to baseline, in the baseline, it's basically this baseline that any non-descending lowercase character can sit on. So I've got that arrow that kind of points at the probably hard to see, very thin black line on the bottom. But in essence, what we're doing is we're trying to get the baseline of that piece of text, and that's done by a y coordinate, a y position from the top down. So 0 being the beginning at the top of the view, and then wherever that baseline is going to be in positive number. So these two APIs, get baseline and get line bounds, are pretty useful. The one thing you'll notice though is when looking in a little bit further is these two lines right here are actually doing the exact same thing. And the reason, if you kind of dig a little bit deeper into that, you'll see is they both end up calling the get line baseline. And so, in essence, I can say these are redundant methods. You could potentially just go ahead and use get line bounds. But more or less what these are doing are, they're basically taking the value that you want. So in essence, the get line, the 0th line that you want to get the baseline for, and then it's actually going and measuring the descent line in the font metrics and calculating the top from that line, and then giving you back the actual value of that. I'm not sure why they have that line commented out. I'm sure it's there for a good reason. Who knows? So yeah, like I said, so these two lines effectively do the same thing. If you call them on one line of text, it's only going to get the single line. If you have multi-lines, it gets your first line for get baseline. And then get line bounds, as you see, takes two parameters. One is the line that you want to get for the text, and the second one that I'm passing null, as I really hate doing, is actually supposed to be a rect. And that rect, if you pass it through, will be filled with actual information specifically to that line of text. So besides the actual baseline of the text, it will give you things like top, left, right, bottom, etc. So if you need any types of information around that, that's a perfect API to use. And then kind of showing the last one, showing that we can do multiple lines. In this case, we only have 2 lines, so the first line basically gets us the baseline for that line of text. So the next one, I told you, I lied to you a little bit. I was going to say we weren't going to go into things that were not shown in Android. This is one of them. I say this because it's kind of interesting to understand some of the next portions of what we're going to talk about. So the mean line is the imaginary line running from the top of the non-ascending lower characters. Hopefully that line's pretty visible. This basically sets us up for some of the other things we're going to talk about, but there is no known Android API in understanding how you can get the mean line for a piece of text. But this helps us when we understand kind of what an ascender is. So in this case, the Ascent Line, which is the invisible line for the marking the furthest distance between the baseline and the top of a glyph. So a glyph is anything, basically any piece of a text that, basically every portion of text or portion of an image that needs to be put together to make a character in a Latin language. Technically, in Android, a glyph is for all languages, but it's supposed to be for only Latin. So in this case, for us to understand the Ascent Line, we have this nice little thing that we can do with the text paint by saying get ascent. But one of the things I found when I was using get ascent was get Ascent doesn't return exactly what I wanted. It kind of the Java doc didn't seem like it was getting the exact kind of one-for-one of what an Ascender is. And so what I found was, better than getting the text paint, we can actually get the font metrics from the text paint and use the top attribute for that. And this will actually get a more accurate view of what the Ascent line is. Now, this is an important thing for text in general, because in a lot of other languages outside of English, ascenders and descenders happen quite frequently. And so understanding their relative position to the rest of the lines of text can help you in making sure that your UI for different localizations shows up properly. And we'll talk more about that here in a little bit. So, as I said, the Ascent for the Ascent line, the font metrics top is probably the best one. The Java doc was exactly what I was looking for: maximum distance above the baseline for the tallest glyph in a font for a given size. And I actually looked at both of these and found that almost every time the font metrics top was a little bit bigger based off of how it's going to actually, how Android knows how to render that font itself. And then, like I said, kind of going the transverse. The other way, the other direction in that, we have, instead of the ascender line, we have the descender line. So similarly, the invisible line for the lowest point of a descender within a font. So basically everything under the lowest point of that baseline is considered a descender for text. And similarly, the descent has kind of the same problem, where font metrics bottom actually gets us a much better reading of what the descenders are for that font. So that's kind of a few of the core for understanding text for characters. But what happens when we want to have lines of text and understand the relative positioning between them? Well, that relative positioning between them is called leading. And so for leading, we have this awesome thing on the text view called set line spacing, and that gives us these two very kind of innocuous looking parameters, add and mult. So add itself is basically adding pixels to each line height for a text view. So if you want to add more leading, which is the distance between each line, you can add just a stock amount of pixels to the bottom of each line and more or less get that kind of gap that you see between these two examples that we have. Now you also have the other one, which is Mult, which is a multiplier, is what they mean, and it's a float multiplier, and it's for the line height. And what it does is it takes the line height that you have currently and then multiplies it by that multiplying factor. So in this case, actually in all cases, the standard multiplier is 1.0. If you want to reduce that, reduce the number below 0. If you want to increase that past 1. So those are really the biggest pieces of typography that I would say you really need to think about when you're dealing with Android and text views. And the next portion before we can actually get to the really good stuff, which is the code for these, is internationalization and localization. And the reason I bring that up is because I've heard a couple times today, and I hear it every day in the office, people misunderstand the differences between internationalization and localization. And in essence, the two are different as such. Internationalization is before you've actually started working on something. So it's the act, and this is a lot of times what we're kind of not used to doing, which is being from the inception point of a product, thinking of ways that we're going to make ourselves easy to be localizable. So making sure that the app will work in other localizations. Whereas localization itself is the act of actually making something meet the language and cultural requirements for a locale. Just in case you know what a locale is, that's a set of parameters that's defined by user's language and country. So it's obvious that for us, really what's most important is probably just the localization. And I'm only bringing up internationalization because I don't think that that's not important. It's just for us right now, it's easier for us to concretely say, to fix the problems for localization. We need to be in the discussion as Android developers of how internationalization should be taken care of, but the localization is the fun part that we actually get to go and sit and code around. So in dealing with localization, Android gives us a couple of great resources. This is one that I put on there just because it's interesting to know, that you can get the locale of a device through the regular APIs that we have. You can get things like, the actual user's preferred locale, their display language, their display country. Those are awesome. They're not super helpful for us when it comes to text views unless you're doing stuff that's outside of XML and text views, in which case they may be helpful for you. What's more helpful is actually the resource qualifiers in the resource directory. So the resource system itself I'm sure a lot of you know if you've done tablet apps, if you've done anything that's non-standard Android that needs to be on devices that are X big or API versions lower than whatever, the resource qualifiers are the best. And in this case, we've got two that we can use to our advantage. The first one is the language qualifier. So in these 4 examples that I have, the last 3 all have a language qualifier of French, Japanese, and English, respectively. Now, the other one that really makes it super powerful for kind of getting, right into the actual full locale details is the country qualifier, which is on the very last one. So you'll notice that the in-between 2, French and Japanese, are both just targeting the actual language itself. So if you have someone that's got their device in French that's in Canada, they're probably going to be targeted in the French resources folder. If they're Japanese and America, have the United States as their region code, they'll probably go to this Japanese folder. But the English and GB, and that R, by the way, stands for region. The GB value there basically says anybody who's English speaking and from Great Britain, this is the resources file for them. So this is super helpful for us. I mean, I think a lot of times, we only think of the resources as being tied to tablets and devices. Hopefully, if you have localized an app before, that's not what you think, but this is super helpful for making that happen. So awesome. Now that we know exactly kind of some understanding of what topography is and how we can use topography in Android, and as well some of the localization things that we have, let's go ahead and look at localization in Android specifically with text views. So if you actually were to go and look this up today, Google has a great localization checklist that they give you. But the thing that I've noticed on this is that, first and foremost, the second one should say design for localization and developing for layouts, because they don't really say that. They give you some ideas on how to develop for your layouts. But only 3 of these things are actually tied to something that we can do as engineers to actually localize our apps. And that was a little unnerving to me, because even though your Android app is something that a business has business needs that you want to understand the design and kind of monetization strategy, from an engineering perspective, if we can't actually make it work, then it doesn't really matter. All the other bullets just are kind of useless. So instead of Google's localization, I've decided to create Elliott's development localization checklist. Super amazing name, I know. I'm very creative. So some of these will overlap with what's going on Google, but I'm going to try to talk a little bit more in detail about what exactly you should do in those. So first and foremost is supporting right-to-left text. So for those of you who haven't seen what right-to-left text looks like, I've actually switched my phone in these 2 instances. It's the same text. You'll notice not very much of a difference, but on the right to left side, you'll notice that it is obviously more right aligned, and you'll notice as well Android switches all of its navigation software buttons, which I didn't realize until I've done this for the first time. In order to do this, we have to start by putting something in our application manifest, which is the supports RTL, which is right to left as true. If you don't do this, anything after this is not going to get you anything. You're just doing it for your own, just for fun and games at this point. So definitely make sure you have that. So in order to actually do, to manage your layouts so that you have the correct margins from, the left to right and the right to left, Android gave us this great API for basically margins and paddings called start and end, but it's only on APIs 17 plus. So if you're a Min SDK, anything below 17, forget about it. However, there is an alternative. You can just keep your own left to right for margins and paddings, and then manage that dependency, and I'll show you later on how to do that in one layout. So just so you understand what that means for both left to right and right to left, in a left to right, your margin start is technically your left margin, and on a right to left, your margin start is your right margin, and Android just covers that up and handles that for you, which is nice. And then vice versa, your margin end is the inside of both of those. So definitely utilize your supporting right to left and making sure you understand when you need to do so, and try to understand what API levels as well you're using if your Min SDK is lower. So next one is actually supporting a localized font, but it's actually trying to make a robust way of using the actual resources to help us not have to do programmatic changes of actual fonts that we're using for different localizations. So first you do that by creating an attribute resource, and you can name this one. Like I said, in my creative fashion, name this debug TextView. So you're creating this this stylable attribute that you want to be able to put on your XML, and you're naming it font. This basically will help you in your actual XML be able to use this attribute, and then hopefully in your custom text view that we'll have later on, switch out between with these strings your font that you're going to be using for each different locale. So next important thing is to actually then go and say in your values for each locale that you want to have a different font. Give the actual string for the relative path for those fonts specifically. So in this case, Noto Sans regular, and you would have them for all. So if we take our last example, there'd be one for Japanese and one for French. That's if you wanted to have a font that's different than those. There's a lot of times where fonts will handle up to 36 languages, I think even more sometimes, but it is something that people need to do. So next, I would definitely heavily suggest basically kind of, abstracting away and extending the text view and pulling out this functionality to just load a custom font in general. And I say this code snippet that I have here is not handling the caching at all, but I want to be very clear. There is a potential that you could leak memory if you are not a good consumer of the typeface itself and actually getting those resources. So make sure that if you decide to go with this path and you want to load a custom font in your text views, that you cache this in memory somehow, or however you like to cache for your app. Hopefully your app has caching. And then lastly, just put this in all of your constructors. You want to basically be able to pull this attribute out of any of your constructors whenever this attribute's used in your XML. And like I said as well, part of it is creating the custom text view itself. And a lot of people would say, creating a text view seems to be a lot of work and a lot of overhead, but because then you have to maintain it. And this is one of the areas where I kind of disagree. I think, the alternatives that I've seen to this, where there's a lot of custom utilities around maintaining your text view. If you look at text view, it handles a lot of these types of things already. I think that this makes sense that your text view should handle loading custom fonts. So I definitely would suggest using it. I've done it quite a bit, and it's been a really amazing experience. So the next thing is one that I early in my career was suspect of doing, but I have since told everybody not to, which is using the include font padding false. So the reason why I say don't include the font padding false is for this specific reason. And I don't know why it pulled the Galaxy Nexus as a device art, but that's a nice throwback for everybody. So the reason I say that is because in languages like Thai, where you have a bunch of ascenders and descenders, and it may be a little bit hard to see, it actually will clip. So that font padding that's in there is built in for a reason. It's built in so that the text view knows how much, or is not allowed to go against how much space the font needs to render in any language. And so in this case, we have a situation where the ascender is completely cut off, and this may mean something totally different in Thai. I don't speak Thai at all, so I can't verify that, but hopefully I haven't offended anybody. If I have, I'm sorry. But yeah, definitely don't do this. And it also happens in English a lot of times, depending on how crazy of a font that you have and what the font file's like. So definitely do not use the include font padding false. The next one is one that I have feverishly tried to break, but always keep going back to, which is only using one layout. And I found it interesting because when I read through Google's localization checklist, the first paragraph that they started talking about layouts really pissed me off. It said, in case you can't accommodate text, to create alternative layouts for languages. And I was really mad because I was like, that's taking the easy way out right off the bat. And then they kind of cleaned themselves up by saying, well, though it's possibly flexible to have alternative layouts, they're harder to maintain, so you should use one layout. I would have flipped these around. I think at all times you should try to use one layout. Just like code duplication is a killer when you're trying to maintain a huge code base, layouts get really unwieldy, and having multiple layouts for multiple different languages and different, tablets, for tablets and different screen sizes, it just becomes out of control. So do yourself a favor and try to use these best practices for localization, and hopefully you shouldn't have any problems. And at the very, very, very last case, then you can use one layout or use multiple layouts, but always use one layout. And the reason I say that is to bring up the example before of supporting right to left. So if we have, API 17 and up, but our app is, 15 or 14 is the min, and then we can't use start and end, is what a lot of people think, just kind of already throwing yourself under the bus. Well, technically from that, you should have two layouts where you have the same code, and in one you have the right and left margins, and in one you have the start and end margins. No, that's not the way to do it. So what you should do instead is actually look back to the resource directory. In this case, we can do a resources v17, which will be anything that supports v17 and above, and then the regular kind of standard values folder, which will support anything below v17 or API 17. And in this case, what we can do is then create a style, which in this case is named localized text view, and then that localized text view now is the style for that one text and that one layout that we have. And now, amazing. At any API level that we want to support, we have a way to support that without having to have multiple code paths, and we can actually change it specifically for each language and for each API, depending on what's used. Next, our span. This is another one that's tough for me to say, but is be careful of spans. And the reason I say this is because about a few months ago, I ran into this. And to kind of get a better look at it, this is a case where, and it's not to pick on the Instagram team because it's an amazing app, but this is a situation where having one span, one text view has really kind of killed the whole experience because this one dude knows how to troll everybody really well. So I definitely would be very careful about using spans. I'll also be very careful about using multiple text views. Obviously, anytime that you have to increase your view hierarchy and make this a much kind of bigger hierarchy, it's harder for the system to actually draw everything, and it takes up precious cycles. So I understand that. But just realize if you have user-created content, that this is the potential thing that you could be getting yourself into, and this puts more importance on things like using Espresso or Robodium for system testing, so this kind of stuff happens. If you can figure out how to test for this in Espresso and Robodium, then you should win some kind of huge award, because that would be amazing. I don't even know how you would do that. So yeah, don't span everything, try to kind of look at both sides of it, right? The last one is kind of what I talked about a little bit in regards to kind of some of the clipping and font issues that we had in the font padding, but it's a little bit more specific to actual line height and the addition and multiplication for line heights. So let's say there's an instance where a designer, and I've had this experience, in fact, a couple months ago, where a designer wanted the leading for text to be much tighter together. And so we went through, and after some iteration, we decided that the line spacing multiplier of 0.8 was the best way for us to go. Well, first and foremost, I noticed even in my debug app that the G on dog no longer has a descender. But even more so, in different languages, now you have the problem where the ascenders and descenders now are colliding with each other. So the problem of cutting off text is now completely exacerbated by having text that overlaps itself. We might as well just go ahead and put all the lines together on one, reduce it to one view, then you can put it on where. Damn, awesome. Now you've created a new language too. So definitely be very careful with this. And there's a really great way of handling this. First and foremost, as I showed in the previous one, I'll go back a couple slides, the font that I'm using here, I think it's just stock actually, totally as clipping, so there needs to be need to solve the problem for that. But let's say we had that solved. One of the things we can do is once again utilize the resources and create ourselves a integer value, and in essence we would have for Thai a values dash Thai, and then the integers XML, and we would have different values between those. So if we wanted to have 0.8 in English and it was make those line spacings really tight, that's awesome. In Thai we may have to have it a little bit bigger so that it's readable, and then designers may not be happy, but people get to read the text, so it's a win-win for everybody. And then last is actually one that maybe some people here have heard of, some people haven't. I know Dan Liu had a really good blog post exposing this, something that I had found at the same time, and was amazed that he found it as well, because it's just like a nook and cranny in the Android world, but pseudolocalization. So in essence, what pseudolocalization is taking your text view and just throwing a whole bunch of crap in there so that it shows what it would look like with lots of ascenders and descenders and weird kind of things, weird glyphs added to your text, so that you can debug your text views and your app without it shipping to anybody. So really simple. In Gradle, if you don't have your debug already there, it's there by default. Well, it's hidden by default. Just add your debug build type. Do the pseudo locales enabled equal to true. And then the next part, I'm not going to suggest any of them. Go find an app that allows you to change your localization for your phone. And what you're going to want to change that to as en_xa. And that's the key to get this monstrosity. So this, like I said, even though it's still English somewhat, but this is super helpful, because now you don't have to go through every single language to test that your text view is respecting the line heights, respecting X, Y, and Z. You can tell right off the bat that where the line spacing looks a little bit too tight for a lot of the ascenders and descenders on the first line. Maybe we would want to, look at some languages that potentially have more ascenders and give them some more kind of line height, some multiplier for their line height, so that it just a little bit more room between them. So yeah, I think this is kind of really to tie it all together. This is the best way to now kind of come and actually test your text view and look at all those things while you're developing. So now that you have all of that, you can go and localize all of the Androids. And thank you very much, and we'll take questions. What's up? Oh, the last language? 1 second. So the last language, it's technically XA. I don't even know what that actually goes to, but it's en_xa. And I'll post all these slides as well on speaker deck probably. Here. Cool. I saw you had your hand up a while. Sorry. Before we entered topic number 5. Let's do it. One more? There you go. Yeah, so basically he was suggesting that you could localize the dimension itself and then support them. Yeah, that's totally a way of doing it. I mean, I think the only reason I do this is because it's a little bit easier to see. So first and foremost, this is an API issue. Obviously, it could be a localization issue at some point, but it's because anything below 17 doesn't support start and end. So yeah, I think the problem you'd run into is with the one layout, you're still going to get errors though from the lint's going to basically say, hey, you have an API that you can't do on your min SDK. Yeah. On Instagram, how do you make that happen? Oh, how did they do that? Okay, so the question was, how did they do on the Instagram slide? How did someone make that happen? So this is actually fairly simple. One of my QA members showed me after he did this to my app, after I found this and then showed me. So you would actually just download the Thai version of the keyboard, and then there's some ascenders that you can use in Thai to just keep adding them on top of letters. And so you just basically keep pressing it, and it will just fill up. And in one text view, this would still break. An alternative that you could use is maybe trying to, reduce the key input for that specific, text character. But then you start getting this really weird where you're going to have to try to support weird input for different, different languages and try to gate all of that from a filter. I just say sometimes it's best not to use a span. It does what? Yeah, so the question was the pseudolocalization only does strings. I don't think it's going to do anything. I mean, because there's no way of saying like this is a certain metric value. In that case, like you're talking about like numbers or something like that, or. That's a great question. I can't say that it wouldn't. It probably could. I mean. Oh, you're saying it doesn't. Yeah, that's great. You have the answer then. Yeah. I've never seen that happen, but I haven't tried it. It's a good question. Cool. Awesome. Thank you.